All right, so today, let's dive into quantum computing.
Yeah.
You know, those mysterious machines we often see in sci-fi movies,
Yeah.
humming away in a secret lab, solving impossible
Yeah.
problems.
Right.
Not quite there yet, but
What quite?
but researchers at Oxford just achieved something pretty remarkable
Yes.
that pushes us closer to that future.
They managed to link two quantum processors together,
Oh, wow.
kind of like snapping together Lego bricks
Okay.
to build something bigger. And what's really exciting
Yeah.
is they didn't just theorize this.
Right.
They actually built it, tested it,
Wow.
ran a real quantum algorithm on this interconnected system.
So it's not just a theoretical paper.
It's not.
It's an actual working prototype.
It is.
Yeah, that's incredible.
Yeah.
For those of you out there following the quantum computing space, one of the biggest challenges has been scalability.
Right.
Building these massive
Yeah.
single-device quantum computers.
Yeah.
It's like trying to balance a whole city on a single, impossibly delicate foundation.
Precisely. And this is where the Oxford team's work gets really interesting.
Okay.
Instead of trying to create one giant monolithic processor, they're exploring a modular approach,
Okay.
connecting multiple smaller processors together.
Gotcha.
Think of it like building a city block by block,
Oh, yeah.
creating a network of interconnected quantum cores.
Okay, I'm starting to see how this could be a game changer.
Yeah.
But how did they actually connect these processors?
Well,
What's the secret sauce?
the magic ingredient here is quantum teleportation.
Okay.
Now, before you conjure up images of Star Trek,
Right.
it's important to understand that we're not talking about teleporting matter,
Gotcha.
but information.
Quantum teleportation. I have to admit, even for someone who follows tech,
Yeah.
that sounds a bit like science fiction.
It definitely has a certain sci-fi ring to it.
Yeah.
But the underlying principle
Okay.
is rooted in quantum entanglement.
Okay.
Imagine two particles linked in such a way.
That if you measure the state of one, you instantly know the state of the other, no matter how far apart they are.
Oh, wow.
It's like having two coins that are magically linked.
Okay.
If one lands on heads, the other instantly flips to tails, even if they're on opposite sides of the universe.
Whoa, that's a wild concept.
Yeah.
But how do you use that to send information between processors?
So the Oxford team used optical fibers to connect the processors
Okay.
and then exploited this entangled link
Okay.
to transmit information, not through physical bits traveling through wires,
Yeah.
but through this instantaneous connection
Right.
between entangled particles.
So it's not like sending data packets over the internet. It's
Right.
more like the information just appears at the other end,
You got it.
thanks to entanglement.
Yeah, and the team at Oxford didn't stop at just teleporting raw data.
Oh,
They took it a step further,
okay.
teleporting what are known as logical gates.
Now hold on, just
Sure.
remind me what those are again.
It's been a while since my computer science classes.
So logical gates are essentially the building blocks of any computation.
Yeah.
They're the fundamental operations that allow a computer to process information.
Right.
Like the AND or R and NOT gates you might remember from logic circuits.
Right, yeah, okay.
By teleporting these gates, the Oxford team essentially created a way for the two processors to work together as a single unit,
Okay.
executing complex quantum algorithms across this distributed system.
So it's like they're weaving together the computational power of these separate processors
Yeah,
using quantum teleportation as the thread.
that's a good way to put it.
That's incredible. But how do we know this actually works?
Right.
Did they just teleport random bits back and forth?
Not at all.
Oh.
They put their system to the test by running Grover's search algorithm,
Okay.
a classic quantum algorithm that demonstrates the power of quantum computation.
Okay.
Imagine trying to find a specific book in a library with millions of volumes.
That sounds like a nightmare.
It would be. A classical computer would have to search each book one by one,
Right.
which could take forever.
Yeah.
But Grover's algorithm exploits quantum principles
Okay.
to speed up the search dramatically.
Hmm.
The fact that the Oxford team successfully ran this algorithm across their two linked processors
Yeah.
proves that their system can function as a unified distributed quantum computer.
Okay, this is where things get really interesting for me.
Yeah.
We've established that they've made a distributed quantum computer,
Right?
and it works.
Yes.
But what does this mean for the average person?
Right.
How will this technology impact our lives?
Well, the potential applications are mind-boggling.
Okay.
Imagine faster drug discovery,
Okay.
where we can simulate complex molecular interactions at an unprecedented level, leading to personalized medicine tailored to an individual's genetic makeup.
Wow.
Think about breakthroughs in materials science,
Yeah.
creating entirely new materials with properties we can only dream of today.
So we're talking about everything from life-saving medicines
Potentially, yeah.
to revolutionary new technologies.
And that's just the tip of the iceberg.
Oh, wow.
This distributed approach could also pave the way for more powerful artificial intelligence and machine learning,
Right.
leading to breakthroughs in fields like robotics,
Uh-huh.
data analysis, and even, dare I say, sentient machines.
Whoa, now that's getting into some serious science fiction territory.
Yeah.
But let's not get ahead of ourselves.
Or-
We are talking about a technology that is still in its early stages, right?
Absolutely.
All right, so let's talk about those challenges.
Yeah.
What are the roadblocks standing between us and this amazing quantum future?
One of the biggest challenges is improving the fidelity of quantum teleportation.
Okay.
Currently, there's a small chance of errors occurring during transmission,
Uh-huh.
which can corrupt the information and affect the accuracy of computations.
It's like trying to have a phone conversation with a bad connection where some of the words get garbled.
That's a good analogy. In a normal phone call, a few dropped words might not be a big deal.
Right.
But in the realm of quantum computing, even a tiny error can derail an entire calculation.
Gotcha.
Researchers are exploring ways to make quantum teleportation more robust and error-free, ensuring that information is transmitted with perfect fidelity.
Okay, that makes sense.
Yeah.
But aside from the fidelity issue, what other challenges are there?
Well, another major hurdle is scaling up the system.
Okay.
The Oxford team successfully linked 2 processors,
Right.
but to build truly powerful quantum computers,
Yeah.
we need to connect many more.
Uh-huh.
Imagine hundreds, thousands, maybe even millions of processors working together in a vast quantum network.
That's a massive engineering challenge.
Exactly. How do you physically connect so many processors?
Right.
How do you manage the communication between them? How do you ensure that the entire system remains stable and reliable?
Yeah.
These are questions that researchers are actively grappling with.
It sounds like we're talking about more than just quantum physics.
We are.
We're talking about building the infrastructure for a whole new kind of computing.
Precisely.
Wow.
It's a multidisciplinary effort,
Yeah.
requiring expertise from fields like physics, engineering, computer science,
Right.
and material science.
Wow.
But the potential rewards are so great
Yeah.
that researchers around the world are dedicating their careers to making this vision a reality.
Yeah, this is really exciting stuff.
It is.
I'm really glad we're covering it.
Me too.
Yeah.
Yeah, it's a fascinating challenge, and it's drawing in some of the brightest minds from around the globe.
Yeah.
This isn't just about building a faster computer.
Right.
It's about creating a fundamentally new way of processing information.
Okay.
One that harnesses the strangeness of quantum mechanics to solve problems that are simply intractable for our classical computers.
And that brings us back to Grover's algorithm,
Yes.
which the Oxford team successfully ran on their 2-processor system.
They-
It seems like more than just a proof of concept.
Yeah.
It hints at the types of real-world problems these distributed quantum computers could tackle.
Absolutely. Grover's algorithm,
Yeah.
while often explained, using the library analogy, has far broader applications.
Okay.
It's essentially a search algorithm, but not just for finding books.
Right.
Imagine searching for the optimal configuration of a complex molecule to design a new drug, or finding the best route for a delivery truck through a congested city.
So it's about finding the needle in the haystack.
Yeah.
But that haystack could be anything.
Right.
A massive database, a complex system, even the vast landscape of possibilities in a scientific problem.
Exactly. And the beauty of Grover's algorithm
Yeah.
is that it offers a quadratic speedup over classical algorithms.
Okay.
This means that for certain problems, a quantum computer could find a solution in a fraction of the time it would take.
Wow.
Even the most powerful supercomputer we have today.
That's incredible. It opens up a whole new world of possibilities.
It does.
But I have to ask,
Sure.
if this technology is so powerful,
Yeah.
are there any potential downsides?
Hmm.
What about the ethical implications?
That's a crucial question. Any technology this powerful has the potential for both good and bad. One area of concern is cryptography.
Okay.
Much of our modern cybersecurity relies on encryption algorithms that are difficult for classical computers to crack.
Right.
But a sufficiently powerful quantum computer
Yeah.
could potentially break these codes, rendering our current security measures obsolete.
So it's a double-edged sword.
It is.
The same technology that could lead to medical breakthroughs could also be used for malicious purposes.
It's a reality we have to confront.
Yeah,
However,
yeah.
there's also ongoing research
Okay,
into developing quantum-resistant cryptography,
gotcha.
essentially creating new encryption methods that can withstand even the power of quantum computers.
Okay.
It's an arms race, but one we need to engage in to ensure a safe and secure future in the quantum age.
Okay, so it's not all sunshine and roses.
Yep.
Right. But it's not all doom and gloom either.
No.
There are challenges.
Yeah.
But also potential solutions.
Yes.
It feels like we're on the cusp of something truly revolutionary, something that could change the world as we know it.
It's a sentiment shared by many in the field.
Yeah.
And the potential goes beyond just raw computing power.
Right.
We've touched on this earlier, but it's worth diving a bit deeper.
Okay.
The possibility of a quantum internet.
Yes. The quantum internet.
Yeah.
It's a concept that's been floating around for a while.
It has.
But the idea of actually building such a network still feels like something out of science fiction.
It does, but the building blocks are starting to fall into place.
Okay.
Remember those entangled particles we talked about earlier?
Yes.
They're not just useful for connecting processors within a single quantum computer.
Okay.
They can also be used to establish secure communication channels over long distances.
So instead of sending data packets through fiber optic cables,
Yeah.
we'd be transmitting information through these entangled links.
Precisely. And this type of communication would be inherently secure.
Oh, wow.
Any attempt to eavesdrop on the transmission would disrupt the entanglement,
Mm-hmm.
immediately alerting the sender and receiver to the intrusion.
That's incredible.
Yeah,
It would be like having unhackable communication channels.
exactly. And it's not just about security.
Okay.
A quantum internet could also enable distributed quantum computing on a global scale.
Okay.
Imagine quantum computers around the world
Yeah.
all linked together through this entangled network,
Right.
collaborating on complex problems that would be impossible for any single machine to solve.
Whoa. A global network of quantum brains.
Yeah.
All working together in perfect synchronicity.
It's amazing.
The implications are mind-boggling.
They are, and while a fully realized quantum internet is still some years away,
Right?
the research and development are progressing rapidly.
Mhm.
We're seeing breakthroughs in entanglement generation,
Uh-huh.
distribution, and manipulation.
Right.
All essential components for building this future network.
It's like we're laying the foundation for a whole new era of interconnectedness.
Yeah.
One that leverages the bizarre but powerful laws of quantum mechanics to connect not just machines,
Yeah.
but also ideas and minds across the globe.
It's really quite something.
It's truly inspiring.
It is. And as with any transformative technology,
Yeah.
there will be challenges and ethical considerations to address,
Right.
but the potential benefits are so vast that it's a journey worth embarking on.
Mm-hmm.
We just need to proceed thoughtfully and collaboratively,
Right.
ensuring that this technology is used for the betterment of humanity
Yes.
and not for its detriment.
This has been an incredibly fascinating conversation.
It has.
I feel like we've only just scratched the surface of what's possible with distributed quantum computing.
Yeah.
But I want to pause here and hear from our listeners.
Okay.
We have an amazing community of tech enthusiasts from all over the world,
We do.
and we'd love to get your take on all of this.
Yeah.
What excites you the most about this technology?
Mm-hmm.
What concerns do you have?
Right.
Let us know in the comments below.
Yes, we want to hear from you.
Yeah.
Are you optimistic about the future of distributed quantum computing?
Mm-hmm.
Do you think it will live up to the hype?
Right.
What role do you think it will play in shaping the world of tomorrow?
We believe that conversations like this are crucial for navigating the complex landscape of emerging technologies.
I agree.
We need to engage with these topics,
Yeah.
explore the possibilities, and consider the ethical implications.
Absolutely.
And we need to do it together
Right.
as a global community.
So join the conversation.
Yes.
Share your thoughts, your questions, your hopes, and your fears. Together, let's explore the depths of this quantum frontier and chart a course towards a future where this transformative technology benefits all of humanity.
Okay, before we wrap up this incredible deep dive,
Yeah.
I want to touch on something that's been on my mind throughout this discussion. The sheer audacity of this research. We're talking about harnessing the most fundamental laws of the universe,
We are.
the very fabric of reality,
Yeah.
to build a new kind of computing machine.
It is audacious.
Yeah.
And it's a testament to the power of human ingenuity and our insatiable curiosity.
Yeah.
We're not content to simply observe the universe. We want to understand it, to manipulate it, and to use its own laws to create something new and wondrous.
It's like we're reaching out to touch the stars.
Yeah.
Not with rockets and spaceships,
Right.
but with the power of our minds and the tools of mathematics and quantum mechanics.
And who knows what we'll discover along the way?
Yeah.
What new knowledge will we unlock? What
Wow.
new possibilities will we create? It's an exciting time to be alive, to witness this unfolding revolution in computing, and to be part of the conversation that will shape its future.
I completely agree. It feels like we're standing on the threshold of a new era,
Yeah.
one that's filled with both promise and uncertainty. But one thing is clear.
Yeah.
Distributed quantum computing is no longer a theoretical concept confined to research labs and science fiction novels.
It's not.
It's a reality that's rapidly taking shape,
Yes.
and it has the potential to reshape our world in profound ways.
Indeed. And it's a journey we're all on together.
Yeah.
So buckle up, folks.
Okay.
Because things are about to get very interesting.
Okay, before we sign off,
Yeah.
I have one final thought for our listeners out there.
I'm all ears.
Welcome back to our deep dive on distributed quantum computing.
It's great to be back.
And wow, what a conversation it's been so far.
It has.
Our global community of listeners really brought the heat in the comments,
Yeah, they did.
sharing incredible insights, thought-provoking questions,
Right.
and even some healthy skepticism,
Yeah.
which is always welcome.
Always.
Absolutely. It reminds us that science isn't confined to labs and research papers. It's something we can all engage with,
Right.
explore,
Yeah.
and even help shape. Now, before we wrap things up,
Okay.
I want to take a step back
Sure.
and consider the broader implications of everything we've discussed.
Sure.
We've talked about the technical marvels, the potential breakthroughs,
Right.
and the ethical considerations.
Right.
But what does it all mean in the grand scheme of things?
I think one of the most profound takeaways is that distributed quantum computing isn't just an incremental step forward.
Okay.
It's a paradigm shift in how we approach computation.
Okay.
We're moving away from the traditional model of a single centralized processing unit and embracing a more interconnected,
Yeah.
decentralized approach.
It's like comparing the old school landline telephone network to the internet.
Yeah,
The internet revolutionized communication by connecting billions of devices across the globe,
right.
allowing them to share information and collaborate in ways never before imagined.
Precisely, and just like the internet transformed our world, distributed quantum computing has the potential to usher in an era of interconnected intelligence, where quantum processors around the world collaborate to solve problems that have long been considered intractable.
It's like tapping into a collective consciousness of quantum minds,
Yeah.
each contributing its unique processing power to solve grand challenges in medicine, material science, artificial intelligence, and countless other fields.
Absolutely.
It's a vision that both excites and humbles me.
It's a humbling thought indeed.
Yeah.
And it invites us to contemplate the nature of intelligence itself. Are we simply creating faster machines, or are we, in some sense, birthing a new form of intelligence?
Wow.
One that leverages the principles of quantum mechanics to transcend the limitations of our classical world.
Yeah.
It's a question that philosophers and scientists will likely be pondering for decades to come.
And a question that I suspect doesn't have simple answer.
Probably not.
But that's the beauty of it, isn't it?
It is.
The unknown is what drives us to explore, to discover, and to push the boundaries of human knowledge.
Absolutely, and that's what makes this field so captivating.
Yeah.
It's a journey into the unknown, a quest to unlock the secrets of the quantum realm and to harness its power for the betterment of humanity.
So, as we conclude this deep dive,
Yeah.
I want to leave our listeners with a final thought.
Okay.
Something to ponder as they navigate this exciting and uncharted territory.
I'm listening.
Imagine a world where distributed quantum computing has reached its full potential.
Okay.
Quantum processors are interconnected across the globe, collaborating seamlessly to solve the grand challenges of our time.
Wow.
Disease is eradicated, energy is abundant and clean,
Yeah.
and poverty is a distant memory.
Okay.
It's a utopian vision, perhaps,
Yeah.
but one that's within the realm of possibility
Right.
if we harness this technology wisely and responsibly.
It's a vision worth striving for, but it won't happen overnight.
Right.
It'll require sustained effort, collaboration,
Yeah.
and a willingness to embrace the unknown. And it will require a global community of engaged citizens.
Right.
People who are curious, informed,
Yeah.
and willing to ask tough questions.
And that's where you, our listeners, come in.
Yeah.
We need your voices, your insights, and your passion to help guide this technology towards a future that benefits all of humanity.
Right.
So keep those minds engaged.
Yeah.
Keep those questions coming, and keep exploring the world around you with a sense of wonder and possibility.
And if you enjoyed this deep dive,
Yeah.
don't forget to like, subscribe, and share it with your friends.
Yes.
Let's spread the knowledge and spark those conversations that will help us navigate this incredible quantum future.
We believe that everyone has the potential to be a deep diver, to delve into complex topics, and emerge with a deeper understanding of the world around us.
Yeah.
So join us on this journey of discovery.
Okay.
Together, let's explore the depths of human knowledge and unlock the secrets of the universe, one deep dive at a time.
Until next time, keep exploring.